Hi, and welcome to the Power Hungry Podcast. I'm Robert Bryce. On this podcast, we talk about energy, power, innovation, and politics. And I'm very pleased to welcome my friend, Jesse Ausubel, to the podcast. Jesse, welcome to the Power Hungry Podcast.
Good to be with you, Robert.
Now, we've known each other a while, and I could give you a long bio and a long bit of praise here. But Jesse, you know, I ask my guests to introduce themselves. So if you don't mind, please introduce yourself.
I'm Jesse Ausubel, Director of the Program for the Human Environment at the Rockefeller University, also adjunct faculty member at the Oceanographic Institution in Woods Hole, Massachusetts. I count fish. That's what I'm best known for. More broadly, I'm interested in elaborating the technical vision of a large, prosperous society that emits little or nothing harmful and spares large amounts of land and sea for nature.
That's a very good summary. Thank you. So you count fish. Well, you now have I don't know if it's a fish or how it would be classified, but you have thanks to your work on the Census of Marine Life, you have a species named after you. What is that? Tell me what that is.
Yes, both a species and a genus, in fact. A species of lobster discovered in the Philippine Sea, east of the Philippines, about 4,000 feet down. Ausubel's mighty claw lobster, the Dinochelys, like dinosaur, Chelys means claw, Dinochelys ausubeli. The original specimens that were found are in the Natural History Museum in Sydney, Australia, and in Paris. The Natural History Museum there, I've visited them both. And more recently, a genus of bryozoans, a kind of moss-like sea animal, was named for my family. Well, for me, it's called the Gessithoa. So we now have both the Dinochelys ausubeli and the Gessithoa. It's one of the great reasons to work in taxonomy, ocean science, marine science, biodiversity, that you can acquire immortality.
Ausubel's mighty claw lobster. That's the name. That's the yes. Common name. I love that.
It has one very large claw, as most lobsters do.
Mighty claw. I love that. I wish I'd like to have anything mighty next to my name would be awesome. So you've been busy, and you introduced yourself. Just a quick bit of background. You've co-authored something like 160 different articles, reports, or authored or edited 160 articles, reports, and books. Your work on dematerialization, decarbonization. We're going to talk about all of that. The Census of Marine Life, the Encyclopedia of Life, the International Deep Carbon Observatory, International Quiet Ocean Experiment. You're involved in all kinds of different things. What are you working on now? I want to talk about a lot of those things, but what's the focus at the moment?
A lot of marine science, a lot of development of new techniques in genomics and also acoustics and signal processing to try to identify both the kinds of marine life, the species, and also the abundance of marine life. So a lot on that front. I'm also interested always in technical change, technical progress, and a lot of our focus now is looking at humans from that point of view. Of course, we've looked at automobiles and light bulbs and many things like that over the years from the point of view of technical change. But we've been trying to apply the lens of technical change that ordinarily one would use for machine objects, chimneys, tractors, whatever, to humans themselves. It's a kind of study of human performance enhancement. And one aspect of that is trying to obtain and sequence the DNA of Leonardo da Vinci, who had extraordinary visual acuity, which is an attribute which, of course, many humans would like to have or improve what they have. You see, I'm wearing eyeglasses, so I have a particular interest. It would be great to have eyesight like Leonardo.
And when you say visual acuity, what do you mean by that?
Leonardo saw better than people normally do, both in space and time. So in space, you could think of it as pixels. If you think of the way the image on your cell phone has improved over the years, if you magnify Leonardo's very small drawings, many of them are really just a few inches high, and even his most famous drawings, like the Vitruvian Man, is a small sheet of paper. They can be magnified 10 or 20 or 30 times, and they're still perfect. So he could see extreme detail. He could also make very, very small drawings, drawings that are almost hard to see normally with the human eye. So that's visual acuity in space, and visual acuity in time refers to a phenomenon called flicker fusion. If you recall, Robert, silent films and early movies that had fewer frames per second, so you could see each frame, and then as the frames become more frequent, it looks continuous to a human eye. Different animal species are able to, so to say, watch a movie at different rates. So let's say a mosquito or other kinds of flies may be seeing not the 48 frames a second that a human may see, but 150 frames a second, which helps them to evade you when you're trying to swat them. So to them, a human might appear as if in slow motion to a fly, so to say. So humans don't all have identical flicker fusion rates, and we think Leonardo may have had exceptional resolution in time. Let's say perhaps he saw 60 or 70 or 75 frames per second. And that might have enabled him to make the extraordinary drawings that he did of the motion of water, of dragonflies in flight, the motion of the wings of dragonfly, of birds in flight. Most of us simply can't see, much less draw, what he saw. So he had extraordinary visual acuity.
There's one thing, this is just maybe random, but you mentioned his ability to draw and make very small drawings and yet have them be very accurate. It just brings to mind, I read a biography of Isaac Newton. I've forgotten who the author was at the moment, but Newton apparently, because paper was in very short supply, he drew very small on some of his notebooks, and that was one of his then characteristics later, was his ability to make notes on very small pieces of paper. Was that part of Leonardo's? Why was he drawing so small? Why making such small figures?
Well, paper was very expensive. This was early in the days of paper. Paper was really a byproduct, I'd say, of industrial ecology. As linen, as textiles were more produced in larger quantities, and the societies became wealthier, so did the number of rags, the amount of rags, the quantity of rags that society discarded. And rags, of course, linen rags especially, were the first basis of paper. So paper was a kind of secondary usage of materials. And as the textile industry expanded in places like Tuscany and the Low Countries, and societies had more woven clothing that they could throw away, in contrast to, let's say, clothing made from deer skin or other hides. Paper began to be introduced, and it was the falling price of paper, of course, which was very important in the development of the printing press also, because paper was phenomenally expensive. You weren't going to print 1,000 copies of anything anyway. Right. So at Leonardo's time, paper was still expensive. He bought large blocks of it, would cut it up into the small sheets, and then wrote on both sides, perhaps 15,000 pages of notebooks in the course of his life, about half of which appear to survive. But he used every bit of paper, and his first biographer, Vasari, wrote also that Leonardo had hands of stone, meaning that he could draw very straight lines, or draw very carefully, and write and draw on make these very small drawings. He may have also made small drawings sometimes for his own amusement or to hide things. He liked to write backwards also, mirror writing. And so making very small images, micro images, may have been a way also of being discreet.
Well, so since we're talking about Leonardo, and I want to come back to one of the things that, the first thing that first bit of work of yours that brought your name to my attention was an article that you wrote in 2007 called Decarbonization and Nuclear Heresies. I'm looking at my notes here. I'm not seeing it right off the top of my head, but let's continue with Leonardo for a moment, because what was the origin of this? In looking at the news clips that you and your colleagues have found 14 living descendants of Leonardo, what was the origin of this project?
Well, the interest in Leonardo goes back actually about 25 years to my mentor, Italian physicist Cesare Marchetti, with whom I first worked on decarbonization and other subjects
Right.
I'm sure we'll turn to.
Right.
I was talking with Marchetti one day, and he said to me in a kind of casual way, he said, "Well, of course you've studied Leonardo." And I said, "No." And of course, for Italians, studying let's say some of the notebooks and the work of Leonardo is like studying Shakespeare for English speakers, or Goethe for French speakers, or Tolstoy for Russian speakers. He's so central to Italian culture. So as part of a normal good education in Italy, one has a lot of exposure to Leonardo. But of course, growing up in America, that's simply not true. You may know about Mona Lisa or something, but with some tutelage from Marchetti, I started exploring Leonardo, and of course he's infinite. It's like the oceans or astronomy. The enormous body of work, enormous variety, great insights into nature, into humanity, into beauty. And in 2014, Marchetti and another colleague of ours, Brunetto Chiadelli, a physical anthropologist at the University of Florence and expert on bones, we were sitting around one day and talking, and Brunetto actually was the one who said, "Well, among us, we have the knowledge and contacts to try to obtain and sequence the DNA of Leonardo." And we looked at each other and said, "Well, why don't we try?" So we involved another outstanding paleontologist, Henri de Lumley, from the Institute of Human Paleontology in Paris. And we set off on this quest, which continues. I hope in the next 1 to 2 years we'll succeed. Along the way already, we've learned many things and developed some powerful forensic techniques for obtaining biological traces from sheets of paper. Everybody's used to the idea by now of DNA in the courtroom from, let's say, from Monica and Bill. But people, when you handle a sheet of paper, when you handle a pen or a glass, and of course, the FBI and other police groups by now know this well, you leave DNA, you leave biological traces, cells, every cell has DNA, you may leave other biological traces as well on what you've held. And with the magic from companies like New England Biolabs, it's now possible to do an extraordinary amount on the basis of the DNA from one cell. And so what we're trying to do is we've developed techniques for recovering DNA from ancient paper and from some other surfaces. And we're hoping over the next year or two to compare the DNA that we find from sheets of paper that we believe Leonardo may have handled, including pages of his notebooks or drawings, with DNA from descendants of his half-brothers. He himself had no children, but so
how did you find the 14 living descendants? How have you because you haven't sequenced the DNA yet, right? So you don't know.
No.
You don't have that full information, but you still were able to find 14 living descendants?
Yes.
How so?
Well, some historian colleagues of ours in Tuscany, Alessandro Vezzosi and Agnese Sabato, for a long time have been interested in Leonardo's family And the genealogy has taken on new importance because of the possibility that the living descendants, first, that there are no bastards in between, but that they're true biological descendants of Leonardo's father. If so, they would carry the same Y chromosome. And Alessandro Agnese did extraordinary historical research in archives, documents of various kinds, birth records, last will and testament, all kinds of things like that. And they've been able to build a huge genealogy covering almost 600 years. It's really an extraordinary feat of historical scholarship. It was published on July 5th of this year and received quite a lot of attention around the world. And it leads to as many as 14 possible living descendants, male descendants, who would have a Y chromosome. And several of the descendants have said they'd be excited to participate in the research if they have the same Y chromosome, and if that Y chromosome matches with some of the material that we get off the notebooks or other sheets of paper that Leonardo may have handled, then we really have something. And of course, the paper would have been handled by many other people as well. There's always the problem of contamination. That's why this Y chromosome to match with the living descendants is
so the genealogy work was separate and apart from the DNA work then.
Well, it's a part of the project and necessary, in order to verify that the DNA that we think is Leonardo's DNA, we need some. It's like dual factor authentication, which all of us are using for our banking or whatever. You can't just say, now there's a tomb in the beautiful royal chateau in Amboise in the Loire Valley in France for Leonardo that was built initially about 3 months after his death in 1519, and then changed a few times since then and opened a few times. But it's possible that there are bones or teeth or hairs in that tomb. Of course, it's a beautiful tomb, and there's a real and proper reluctance on the part of the Fondation Saint-Louis, the French entity that controls the chateau and the tomb, to open it. And of course, what's in there may or may not be Leonardo's bones. Sure. There may or may not be anything. They may or may not be in good condition. Right. But at some point, of course, if we have the match from other sources, it's possible that we could also with the cooperation of the French, the right French authorities, it's possible that we could go there. But even if we were to open the tomb first, we would have to compare that to something else, because after all, the bones could have been swapped at some point, or there are other. So
the living descendants then give you that two-factor authentication. So yes, I'm with you. So since we're talking about DNA, let's talk about eDNA, which when you first told me about this, some years ago now, I thought, well, this is as close to magic as science gets. But rather than me discuss it, what is the eDNA project, and how does it factor in with your work on fish and oceans and understanding what's underneath the water, the surface of the seas and the oceans and the ponds that we see?
The eDNA is DNA forensics, you could say, as well. Whenever an animal swims or is in the water, whether it's a fish or a lobster or a clam or a human swimming in Barton Springs, is that the name of it?
That's it, Barton Springs Pool, about a mile from where I'm sitting right here. Yes, love that place. Swim every day if I can.
So from skin cells, from the surface, or fish from the gills, from urine and defecation, from wounds, from saliva, animals leave DNA. So in the water, so-called aquatic DNA. Also, it can wash into a stream or a pond or the ocean from nearby. So if let's say a deer comes down to drink at a pool, of course, from its tongue there might be DNA, but again, if let's say a deer defecates near a pond and then it rains, and some of the DNA will wash into the pond. So you get water is a catchment for DNA from the water itself and from around it. And when you shed the DNA, it's a long string. Of course, the total number of letters of DNA, you can think of the DNA as like a very, very long phone number with, right, let's say, a piece of mitochondrial DNA may have, let's say, 10,000 letters in it. Finally, the full piece. So when it's initially shed, it may be very long. Over the course of a few hours, a day, and certainly 2 days, it breaks up into a lot of short pieces. So if I have a long piece of DNA, I might be able to say this is a very long piece. I might be able to say it's Robert Bryce. If I have a somewhat long piece, I might be able to say this is a Homo sapiens. If I only have a very short piece, I can't say much at all. We've known that there is this loose DNA, environmental DNA, or extracellular DNA in water for about 30 years, but we had nothing to compare it to. We had no reference library. And one of the things that the Census of Marine Life program from 2000 to 2010 did was greatly accelerate the sequencing of the DNA of many forms of marine life. So there are now reference sequences for tens of thousands of marine species in the big DNA libraries like GenBank in the US or BOLD in Canada. And so now, if I go to the river in Austin, or if I go to the Atlantic Ocean, near where I am now, and just get a Gatorade bottle, so to say, of water, and then put it through something like a Melita coffee filter, there'll be a little bit of sediment on that filter, and I extract the DNA from that sediment, and then I do what's called amplifying it, which means you make more copies of the DNA you want, and you can grab, using what are called primers, you can grab exactly the piece of DNA you want. So again, there's lots of different pieces of DNA, but I want DNA that come from a particular gene, let's say the cytochrome oxidase, or from the 16S. These are just different pieces, like saying, I want to grab from sitting, looking behind you, Robert, there's a stool and a chair. And right, let's say I'm interested only in chair DNA. So I get right, a primer which just recognizes chairs. So we do that, and then we'll get a list of sequences, and then I'll match those against a database. And some of those will say this is a wooden armchair, and some will say this is a lazy boy recliner, and some will say it's a
rocking chair or something else, right?
Yes,
yeah, right.
The rocking chair.
So you're applying the same to speciation then, or species, the database that you have on these tens of thousands of other species, and then making the match from there.
Yes, and beyond that, the number of pieces of DNA, let's say the number of pieces of wooden chair DNA, correspond, they're an index of the abundance. So we can not only say, let's say there are bluefish and striped bass or croakers or red snappers, but we can say there are a lot of red snappers or a lot of tuna or a few humpback whales. So it's an extraordinary technique, because all you need is actually about a half a liter of water, even a cup, so to say, and you can collect that with a drone, or you could collect that from a kayak, or you could collect it from a big survey vessel. You can do it. So traditional means of assessing what lives in the ocean involves usually big nets or complex acoustic arrays where you ping and listen for echoes, or scuba divers and lights and cameras. Sometimes traps sitting with bait and cameras. All of these things are much more complex and difficult. And of course, in the case of nets, you're really transforming, you may be harming the animals if you take them out of the water, and you change the environment around them. Here, it's like a blood test, for, let's say now blood test, let's say for cancer. So it's completely non-invasive and no harm to the context. And out of it, you can get a list of the let's say the different kinds of fish or all the vertebrates. We've done freshwater environments where you can also, you're in a place where people are very interested in bats, for example. So bat DNA will be found in streams or ponds
Sure.
because the bats are nearby. So you can do complete, really, biodiversity assessments.
Just with a small jar of water.
Yeah,
I mean,
essentially it's like a blood test. Which now, again, when you go to with 20 or 30 years ago, and you had a blood test, there might have been, let's say, 4 or 5 things that were looked at, maybe cholesterol, whatever. Now, of course, it's a big long list,
right?
Which tells you, again, for example, with regard to cancers. So we've been studying what's the chemicals in water for a long time, the salts, and also radioactive traces, things like that. But we're just learning now to make use of the biological information in a cup of water. And it's a revolution. And really, over the course of this decade, I think it will become the dominant form of surveying aquatic life.
Well, and like I said, it just seems almost magical, and I guess it is magical, really. As a kid, we talked about this before, that I remember watching biologists in Oklahoma, and they would have these electric machines. They would shock the fish, right? And they would have these probes, and they'd bring them to the surface, and that was how they would do the surveys. But and what all the things you described before, the nets, the divers, it was all physical observation. They're seeing the fish in one way or another, either. But now you're just seeing their DNA footprint without having to even capture them or see them, and it's an incredible, as you say. So what's the resistance to this? We talked a little bit about the resistance to the incumbent technologies and why they're going to be slow to necessarily adopt eDNA. Can you just talk about that briefly?
Well, there's a wonderful remark by an early 19th century rabbi: "The loudest sound in the world is a habit breaking." So I would say, first of all,
the loudest sound is a habit breaking. That's funny.
Yes. So first, I would say people have been doing things a certain way for a long time. The same is true in the art world, by the way, where now we think, as a result of projects like the Leonardo project, increasingly it will be possible to use biological traces, DNA, possibly other things, also artificial intelligence, image recognition. So a computer or a 6-year-old child may be able to say whether something is a Rembrandt, and the people have developed whole careers on the basis of connoisseurship and expertise. And in zoology, botany, of course, there is a similar situation. So people are afraid that the hard-won expertise is being devalued. Now, I don't look at it that way. I would say this is another tool to add to the toolkit. I was mentioning the dual factor authentication earlier.
Right.
So obviously all these things are stronger when, genomics are stronger when coupled with acoustics. And the genomics may tell you the animal that's there, but it may not tell you whether it's a healthy animal, or it may not tell you whether it's a 2-year-old or an 8-year-old. So really what we want to do is integrate the genomic techniques with other techniques. But first I would say there's just there is some fear that this will devalue some of the ways that people are currently doing things, and the system of vessels and trawls, and it's highly developed and quite good at what it does.
So there's inertia in the system that exists, and so it's going to be some reluctance to change it.
And then you need people to learn the new skills. I make it sound very easy. It's not quite as easy as I've made it sound. Right. But people need to do some continuing education. Younger people coming out of schools, of course, will have grown up with genomics. So, but for the people currently practicing, and then some of what we learn, of course, is not always to people's liking. When we started doing the so-called DNA barcoding, we made the front page of the New York Times. 2 high school students we were supporting and working with back about a dozen years ago. They did a study of fish that was being sold in New York City fish stores, and a lot of it was being inaccurately labeled. In all cases, something inexpensive being sold as something expensive.
Yeah,
we don't think it was the fish stores.
What a surprise!
Yeah, it was probably the wholesalers, not the retailers who were doing the markup. It's the wholesaler who really has the incentive to take some whiting and call it halibut or scallop, or to take some other inexpensive fish and label it as something more expensive. But there, I was mentioning the tomb in Amboise. Obviously, if it turns out that there are no bones in it, or if the bones aren't from Leonardo, that's not good news. So,
sure.
And so in the art world, there'll be, there's a lot of copying, and it may turn out that some famous works are not what they are believed to have been, so there's a whole set of it's a disruptive. There's no question that the DNA identification in different realms is disruptive, and so some people are nervous. But I have to say the top levels of the National Marine Fisheries Service in the U.S. Chief Scientist there, Cisco Werner, the leadership of NOAA, under Trump administration, Tim Gallaudet, and now Rick Spinrad, Craig McLean, and the current administration have been 100% supportive and are really trying to absorb the new technique.
Let's talk just briefly about the Census of Marine Life, because I think we first became acquainted when you were actively working on that. And how many countries were involved? How many researchers? And what was the bottom line? You found how many thousands of new species? What was it was a remarkably broad and ambitious project, and you were one of the founders of it. It seems like a success by almost any measure. Were you happy with how it came out, and what were the results?
Well, let me step back a little further,
sure,
because I'm worried we're talking too much about subjects that aren't of interest to your listeners, Robert.
Well,
but going back to the start of my career in the late 1970s, I worked a lot on climate change and decarbonization and change of the energy system. And then in the early to mid 80s, I became very interested in dematerialization and the possibility that in the same way we could greatly improve the efficiency of the energy system, we could also greatly improve materials use. And then about 1990, with my agronomist colleague Paul Wagner, we started a whole body of work on land sparing and how much land could be spared for nature. And land sparing is like dematerialization, except for land, or you could say in some ways like decarbonization and trend towards high yields, let me say.
Sure.
But the question was always sort of hanging around when we were working on land sparing and some extent on dematerialization. Also, people would say, well, and Jesse, what about the oceans? So in the mid to late 90s, with marine biologist Fred Grassley, I was trying to learn more about what do we actually know, what are the real observational data about the changes in diversity, distribution, and abundance of marine life. And it turned out that there had never been a global survey of marine life, near shore to mid-ocean, seafloor to sea surface, and seabirds, microbes to mammals. And so Fred and I thought, well, rather than nibble at the edges of these questions, which is really what people have been doing, we decided we would try to organize a global census of marine life, a kind of Noah's Ark effort. So, the tuna people, the squid people, the sponge people, the crustacean people, everybody, and using all the techniques that were available and developing new ones. And fortunately, the then president of the Alfred P. Sloan Foundation, and then Ralph Gomery, mathematician, but who had served in the Navy and also worked in the Office of Naval Research early in his career, really liked the idea and gave us some walking around money to get started, and then gave us a platform for a secure platform for a decade, which enabled us. Sloan provided about $75 million over a little more than a decade. We raised and spent about $650 million in total for the program, and about 80 countries were involved. Let's say, it's thousands of researchers.
Right.
And we were divided into 17 teams. There was an Arctic team and an Antarctic team. There was a seamounts team, and there was an abyssal plains team, and a continental margins team, and a reefs team. And each of these worked on its own, but also together, integrated through a common database, which is one of the most important legacies of the program, the Ocean Biodiversity Information System. And so everybody agreed that by 2010, they would do the best they can, and we would share data and put together a global picture. And so
where can people find that now, Jesse? Is that's online now?
Yes, it's if you search on Census of Marine Life, the full content of the website is no longer there. It was maintained by University of Rhode Island actively to about 2016 or 2017. Now, a good chunk of it is there, but not the whole amount. But overall, the program is very well documented, and there are excellent books summarizing the program as a whole, one edited by Alistair McIntyre, one written by Nancy Knowlton, one by Paul Snellgrove. There is a summary report of which I'm one of the three authors, and all of that is available. And yeah, we discovered about 5,000 new species. We sequenced about 30,000 species and really gave a big boost to the, we made estimates of the total number of marine species. The total number of marine species now already described is about 250,000. But the estimate is that there's somewhere between, I'll say 300,000 and 2 million more still to be discovered. And we did a lot of work on also then trying to understand what controls the diversity. And this, in terms of, I'll say, maybe a little bit of a transition. Of course, the program also, with part of the original motivation for the program, and then what came out of it, is a deep concern about the industrialization of the oceans, something I know you're interested in as well.
I am. So let's talk about that, because that leads to this issue of power density. And just as a quick station break, my guest is Jesse Ausubel. He's the director of the program for the human environment at Rockefeller University. You can follow up on him at phe.rockefeller.edu. So a quick bit of background, Jesse, I think we met maybe 2008, 2007, 2008. You first came to my knowledge in about 2007 for your article, Renewable and Nuclear Heresies, in which you introduced this concept of power density, which I'm not flattering you at all, or as my father used to say, blowing smoke up your skirt, changed the course of my career to understand what power density was and how it matters. And let's go back to that, because it seems to me power density matters in terms of both the decarbonization discussion, because nuclear, as you pointed out in that article, is the densest form of power generation, therefore the greenest. Let me put it this way: how do decarbonization and dematerialization and land sparing, how do they relate to power density? Is that a fair question? Because it seems to me that there's a tie between all of those issues.
Yes, there is. Let me go back to the beginning of my career and fill people in a little bit more. It's 1977. I'm in graduate school working on oil spills and other problems of the environment.
And this was at Columbia.
Columbia. Then I was awarded a fellowship to go to actually a Sloan fellowship to go to the National Academy of Sciences in Washington D.C. And my application had been about petroleum and the marine environment, about which the Academy had published important reports. When I got down there, the people who were advised me, said, well, it's great that you're working on oil spills, but a lot of people are now working on those. Have you thought about working on an atmospheric issue? And I said, no. Although, in fact, I had co-authored a play about global cooling, which I could tell you about when I was an undergraduate. And there were three equally important problems at that time: ozone depletion, acid rain, and global warming, climate change. And I went away for about 6 weeks and read a lot of reports, and I came back and I said, well, it seems like everything needs to be done on this climate issue. And so my mentors were very happy about that. And I spent much of the next 10 years working on the now extremely popular climate problem. And the climate problem, of course, the climate question, it starts with emissions from changes in land use and primarily from the energy system. Then there's the question of the fraction of the emissions that stay in the atmosphere, which could be, and emissions could be nothing, or they could rise by 1 or 2 or 3 or 4% a year. At that time, they had been rising by more than 4% a year in the 50s and 60s and into the 70s. And that's the carbon cycle question. Will 1/3 or a half of the carbon emitted, or 2/3 stay? How much will go into the oceans and into forests and so forth? Then there's the climate question itself. Will the climate change by 1.5 degrees or 3 degrees or 4.5 degrees for a doubling? Then there's the physical effects. Will ice sheets melt? Will the CO2 itself enhance the growth of forests, whatever? And then there's the human effects. What will happen? Will people migrate? Will people be richer or poorer? And so everything needed to be done. Now, this all seems very obvious, but everything needed to be done at the time. And so I ended up being actually one of the, I would say, really only probably one of the first half dozen people in the world to make projections of future emissions of greenhouse gases. The leading figure initially was a civil engineer from Oak Ridge National Lab named Ralph Roddy. And there were a couple of Russians trying to do it. Bill Nordhaus, of course, who then actually won a Nobel Prize for very brilliant work. So I got involved with all these people and worked on all the aspects of the climate question, both especially on the emissions and the impacts. And so I started learning about energy systems, and thanks to positions at the National Academy of Science, National Academy of Engineering, and International Institute for Applied Systems Analysis, I got to visit power plants around the world. I even got to work on the Chernobyl cleanup a bit in the late 80s. So I was, I saw coal mines, I saw coal burning power plants, I saw pipelines, nuclear power plants, and got involved in a lot of analytic work. And with Marchetti, whom I mentioned, and 2 other, I'll say, of his initially research assistants, people who went on to very distinguished careers also on their own, Nebojša Nakachenovic and Arnold Krubler, we started doing all kinds of calculations during the 1980s. I wrote a paper called Climate Change and the Carbon Wealth of Nations, and another paper called Economics in the Air, Introduction to the Atmosphere, Economics, Atmosphere, and Climate. And one of the things we started doing at the based on insights of Marchetti was putting all the fuels that were used into a blender, and then looking at the hydrogen to carbon ratio.
Right.
Marchetti was one of the early advocates and developers of the concept of the hydrogen economy, and so we started making these charts, and we found a monotonic trend in the HC ratio, where of course, fuels can be
HC. You're saying the ratio of hydrogen atoms to carbon atoms, and that over time, the ratio of hydrogen relative to carbon was increasing, right? And that was the move from wood to coal to natural gas, or wood to coal to oil, and now natural gas, and then eventually to nuclear as a long-term trend toward a smaller carbon footprint, or carbon intensity, I guess would be the way to put it.
Exactly. You can think of wood as being 10 carbons for 1 hydrogen.
Right.
coal, let's say, is 1 carbon for 1 hydrogen. Petroleum is 1 carbon and 2 hydrogens, and methane, natural gas, is CH4, 1 C, and
Sure.
nuclear, of course, is 0.
Right.
So we were on the one hand looking at the HC fuels themselves, the hydrocarbon fuel, and the trends, and then we were also looking at the total amount of carbon as the numerator in relation to a denominator of total BTUs or total joules or whatever.
Sure.
And so by those, and there are some other ways you could do it, but basically any way you looked at it, if you went back a few hundred years, you found that this phenomenon of decarbonization, and I think I'm not sure, the word decarbonization might have been used by others in other ways, but I think we started using it in the 80s this way, and I think in that sense, I think we can claim credit for it.
Sure.
Marchetti, by the way, also published the first paper with the word geoengineering, published in 1977, a paper called On Geoengineering and the CO2 problem. And then we were using itself, the word itself. I think I published the first paper with decarbonization in the title or in the abstract in that 1990. But we were charting it and analyzing it in all these different ways. And so, if you looked at the long-term trend, it looked like, again, an evolution of the blend from leadership of wood to wood and hay, you could say,
right.
Very important for the animals, coal, oils, gases, and then to eventually to pure hydrogen. So, and I called this the light path, the light, you could think of LITE, right, or LIGHT, right, because of course you were lightening the weight, so to say, for energy produced. So we became really very excited about this whole notion of decarbonization. And then the question comes, how do you get beyond natural gas? How do you get beyond CH4? And obviously you need a non-carbon source of heat or electricity to get the pure H, which could be fission or fusion, or could be solar and wind in principle. And so then we became interested in comparing the different attributes. But we became convinced, or I became convinced certainly, that I say all of us became convinced that what was driving the system was the spatial density of the at the level of the end user. The spatial density, you can say the joules or the kilowatts, right, that were being used in, say, a barn or a home or a workshop or finally a skyscraper.
Right.
So and what you see with the evolution of cities, of course, is that the power density keeps growing. So the amount of the kilowatt hours consumed per square meter keeps going up. Right. Especially in the 20th century with skyscrapers. So you're having to provide enormous amounts of energy from the hinterland, let's say, and concentrate it. And so to us, it obviously made sense that you would also favor, at the generation side, the systems that would generate densely. So if you need a vast hinterland to provide hay, it's expensive and wasteful. And so if you look, the evolution comes both at the level of the end use toward hydrogen, but we think on the generation side, toward systems, including the machines, obviously, sure, better power plants that are.
So if I could interrupt,
spatial density.
Because as you're talking about this, the way I think about it, or the way I've even written about it, is that when you get to the city where you have very high power densities of hundreds of watts per square meter, you need then, as you say, instead of having vast areas in the countryside in order to make that density work, you need high power density generation systems in the countryside to meet that high power density consumption in the cities. Is that a fair shorthand way to talk about it?
And for all the propaganda, I'll say, about nuclear and solar. About wind and solar, if you do the arithmetic on the wind farms or the solar farms that are being developed now, whether onshore, offshore, offshore in Singapore or Indonesia, floating solar fields, or the 13 megawatt new wind turbines. You find that there's really very little technical progress. Things are getting more extensive. They're making exactly the same mistake that agriculture made before agriculture figured out how to achieve high yields. It's just extension. So it's like Britain colonizing Argentina for wheat or the Americas. So that's what the solar, the so-called renewables are finally, you're getting, let's say, 1.2 watts per square meter from wind, whether you have a lot of small windmills or a few very large ones. And solar, you're getting maybe 7-8 watts per square meter. Solar is better than the wind.
Right.
But they're still extremely extensive, which means then is a link to the dematerialization, because then you need enormous amounts of concrete, steel,
copper, fiberglass,
copper, gallium, whatever you want.
Go ahead.
Yeah. So these become extreme. So what I wrote in that paper, Bob, which you may remember, is that I said renewables may be renewable, but they're not green.
Yeah.
Renewables
and that changed the course of how I thought about things, because I've been writing about energy and power for a while, but the way I've been couching it is the lower the power density, the higher the resource intensity. You have to counter the low power density with other inputs, land, in the case of corn ethanol, fertilizer, in the case of wind, solar, silicon, polysilicon, concrete, et cetera. I mean, they're just remarkably large inputs. But it was one of the reasons why I wanted to have you on the podcast, because that paper did in fact change the course of how it changed my career in thinking about why power density matters and why density is green, whether you're talking about the cities themselves or the power generation, et cetera, et cetera. So let me switch gears here.
Let me just finish.
Yeah, of course.
Another way of saying this is that renewables may meet the decarb test, but they don't meet the dematerialization test, the DMAT test.
Yeah.
They fail it miserably. They also fail the land sparing. So I think it's a mistake. One of the big mistakes that the world is now making is the complete identification of environment with climate. Climate is very important, but land sparing and dematerialization are also extremely important. The way of saying this about dematerialization, I think of the most fundamental slogan in a way for me, for environmentalism, for I'd say my own shade of green, is no new structures. And the implied new structures by the wind and solar economy is it's nightmarish, both on land, and I've mentioned this industrialization of the oceans, covering thousands of square kilometers of ocean with wind farms, and thus with structures in the water column and on the sea floor, and cables to connect everything together, and then of course the vessels to service them, and the further concretization of coastlines in order to provide the specialized shipping and so forth to do all this. So again, they may be renewable, but they're not green. They just miserably fail the dematerialization test and the land sparing test. And decarbonization is great, but it's not enough.
I really like the way you're talking about that, and particularly on the offshore part of this, because I think that's the part that most Americans, most people just simply don't understand. That when you talk about, or you analyze what the Biden administration is talking about in terms of this offshore wind energy build out, where you're talking about 40,000 megawatts, well, even if you assume a 10 megawatt structure, you're still talking about thousands of offshore structures off the eastern seaboard, which is one of the most heavily navigated, heavily fished areas in the world. And it's to your point about the industrialization of the ocean. And in the midst of that, there seems to be in this rush to provide these permits to these offshore projects, which are very controversial, that there's very little consideration for marine mammal migration and these other issues that have traditionally been in the sweet spot of in the environmental movement in general. And that seems to be tossed overboard. And just because, oh, well, these are renewables and therefore they're good, where you're making the absolute, well, you're making a very clear distinction about that idea. They're renewable, but they're not green.
Yeah, we've horribly abused the oceans for hundreds of years. We remove much too much life. Again, we've changed coastlines, destroyed habitats. Where the acoustic environment, humanity probably adds about as much noise to the oceans now as the natural noise. Waves break, ice cracks, rain falls. Animals themselves make noise, so the oceans, there's and the animals communicate, of course, themselves. But we've from shipping, from oil and gas extraction, now from the wind farms, from trawling for fishing, jet skis, tourism. We've really changed the acoustic environment, and the oceans are 100 years behind the land. I like to say we really need to think much more sensitively about what we're doing with the oceans. Of course, people are becoming concerned about the plastics, which is part of the dematerialization problem. Again, I would say the people are really underestimating, I feel, the importance of the dematerialization in the landscape now. There was just a very good study published in May about the entirety of the Czech economy, the Czech Republic, and only 7% of the materials deployed in a new year by the Czech economy are secondary materials. So recycling is, I'll say it's in the broadest sense, we're at 7%. So people are talking about a circular economy and so forth, but 93% of what the Czech economy produces is from new materials. And so when you look at something like this huge materialization, which is implied by solar and renewables, it means just mining the crust just tremendously, just chewing up lots of new material. And of course, the famous and horrible battery question, another area, again, where I feel I've been reading press releases from around the world about batteries for 40 years, and it's a big lie. Batteries are only improving a little bit. The end use has improved because we went from vacuum tubes to solid state electronics. But the actual improvements in batteries, which my group has studied and published some things about, is really quite small. And
the material intensity is enormous. I mean,
well, a Tesla,
Richard Harrington,
a Tesla it's 1,000 pounds of batteries to carry a person who weighs 150 pounds. It's the same as a horse. It's no better. And so it's the old Soviet economy. About half of the coal that the Soviet Union mined was used to transport the other half of the coal in rail cars. And when I see a Tesla, it's like a Soviet car to me, because it's basically just this load of lithium and other things to carry this pathetic cargo. And the same as the so-called power wall. You're supposed to have 1,000 pounds of batteries in your one-bedroom apartment in New York City so you'll have backup in case of it's. And
hope it doesn't catch fire.
Yeah, and this is all being dug up in northern Chile and northern Argentina and southern Bolivia, in beautiful, arid, beautiful environments. And so anyway, it's just a horror. The materialization associated, the thought of there are a billion motor vehicles more or less in the world. The thought of a billion motor vehicles, and of course some of them, the trucks and so forth, will need more than 1,000 pounds of batteries.
Right. Sure.
10 or 20 or 40,000. Anyway, the thought of a billion vehicles with 1,000 pounds of batteries, not to mention if we have to put those into all the residential structures. Electrification, of course, is a dream and great, and more should occur, but it really only fits with nuclear and hydrogen. the idea of 100% electrification in batteries it's so destructive for the environment. It's horrible.
I'm one of my future guests on the podcast. In fact, I just finalized the date on it. It was Richard Harrington, who's the director. He's the head of Earth Sciences at the Natural History Museum in London, who's done some very good work on that analyses on the intensification of mining and so on. So we've talked about offshore wind. We've talked about decarbonization, dematerialization. So what are the biggest, you like big challenges. You made that clear in one of your presentations when you quoted when you got hired on at Rockefeller, the president hired you, said, well, we don't do small projects here. We think big. We think about big ideas and big challenges. Am I remembering that correctly?
It was better than that.
Okay. Well, make it better then, by all means.
Physicist, former president of the university, Frederick Seitz, I went to his office to talk to him about what I might do. And I was babbling like this. And he turned to me and said, well, Jesse, just remember one thing. There's no reason to do anything trivial here.
Yeah, so excellent. No reason to do anything trivial. Nice. I like the way you put that. So nothing trivial. What are the biggest challenges facing I would say all of the people on it? What are the biggest challenges facing humanity today?
Well, on the engineering side, I think there are these, of course, again, we need to break this rule of the ton. I mentioned, the horse or the 1,000 pounds of batteries in the Tesla. And in mobility, there's a way to do that, which is with magnetically levitated trains. Maglevs they don't carry fuel. They don't need an engine or fuel, so they can be light. And we need maglev metros at national continental scale to replace a lot of aviation and to replace a lot of the use of the surface also for transportation. So I'd say, and the Hyperloop, some things in the right direction are now happening in that regard. We started advocating this back in the 80s and wrote a lot about it in the 80s and 90s, published a lot. Anyways, but I'd say making that actually happen in the right way is very important. Zero emission power plants operating on natural gas, but with some capture and sequestration. Operating at very high temperatures and pressures, so you get very high efficiency, and you can get 70% efficiency. That's a huge challenge. Of course, high temperature nuclear reactors that can be used to produce hydrogen. I'm not optimistic about electrolysis. It's another thing which I've been reading about. The U.S. Department of Energy and others are always putting out statements about it, but electrolysis really hasn't improved much in 40 years. I think we have to try something different, and the high temperature thermochemical production of hydrogen, I think, is the way to go. So there are a bunch of on the energy decarbonization side. On the dematerialization, again, we really do need to move in the direction of bits rather than kilos, putting more and more intelligence into the system so that less material is actually needed. And of course, we see that in some ways with things like cell phones, which are also alarm clocks and cameras and so forth.
Right.
But we need to be careful. Mark Mills has written very well about this, that the whole weight and energy consumption of the telecom system isn't so great that we're just displacing the demand, the demand, the electricity demand, and so forth by server farms now is becoming astronomical.
So to put it another way, we need to accelerate these efficiencies throughout all of the systems. Then.
Yes,
is that a fair way to put it?
Yes, and the same is true for
those efficiencies. The big challenge is that those efficiencies aren't diffusing fast enough or occurring fast enough, or we just need to accelerate them.
Well, I think accelerate and choose right. Again, I think some of the good ideas like maglevs and the zero emission power plants, some of these ideas have been around for decades and were not pursued.
Right.
So sometimes things are there on the shelf and not being pursued. In terms of land sparing, on the diet side, there's too much obesity. That's a billion people are overweight. There's 30% or so of all the food that's produced is thrown away as waste. A huge amount of food is wasted by being turned into, especially corn, by being turned into ethanol for cars. Feeding food to cars is stupid. So on the demand side, between reduction in obesity, reduction in meat, or growing meat more efficiently, chickens rather than cattle, or cellular meat, or fake meat, if one wants to go to using beet juice and so forth. So there's a collection of things we can do to reduce demand for food products, but and equally or more important, yields. We can go on raising yields. The genetics, we're nowhere near the ceiling of yields, and the yields around the world are very far below best practices.
I guess the way I'd abbreviate it is we need more densification. We need densification for dematerialization, land sparing.
In the case of agriculture, I think precision agriculture is a better term.
Okay,
because when people think intensity, they tend to think of pouring a lot of fertilizer on a plot of land or a lot of water. But I'm talking about bits rather than kilos, using the water smarter, not irrigating when it's going to rain and so forth. So I think precision agriculture and smarter demand. People talk about hunger and food security, but the real problem on the planet is that we have 50% too much agriculture. We can vastly shrink. A third or more of the land that's now used for the bioeconomy could be released. Ed Wilson is right about half of it. We could have a huge increase in conserved and protected areas. This idea that we have to produce more calories and protein, we're overproducing, which is why 1 billion people are overweight and why a third of food is thrown away, and why Iowa is shoving corn into cars. And farmers can lift yields. So continue to lift yields. So anyway, there should be lots of land sparing. So those are very big challenges. In the oceans, I think we need a kind of moratorium. We just sort of have to say, we're going to pretty much, leave you alone for a while and let you try to recover in a lot of respects. Obviously, shipping and so forth will continue.
Gotcha. So go ahead.
No, you.
Okay, so we've been talking for about an hour, and again, my guest is Jesse Ausubel. He's the director of the program for the human environment at Rockefeller University. You can find him at phe.rockefeller.edu. Now, Jesse, I know you're a sports fan. You have been. You've been a Yankees fan your whole life. You're born and bred New Yorker, been a long-time Yankees fan, but you told me just a little bit ago you don't watch sports anymore. What's up?
When COVID started, sports stopped, and at first I suffered a bit of withdrawal, and then I started reading, and I've always read a lot, but I read sort of professionally during the day. And when I was young, I read lots of fiction and other things. But I started reading a lot of classics that I hadn't read, Canterbury Tales and Decameron and The Betrothed and the Foundation trilogy and War and Peace.
Wait! You read War and Peace?
Oh, it's amazing. All these things are famous for a reason.
For the number of people who start reading it and then don't.
He's so profound about history and some of these subjects that we're talking about. I read 4,000 pages of the Pallisers, the Trollope series about politics and Britain in the 1870s.
It wasn't discussed about doping or about just disenchantment with the big salaries or the corruption in sports. It was more just your own.
Well, then I started, from time to time, as things started up again, I would turn on the sports, and I feel like it's been degraded. All these games that were meant to be 2 hours long now take 3.5 to 4 hours.
That's a problem. Yeah.
It's always advertising. And then in regard to baseball in particular, I feel the game really has deteriorated in the sense that I really dislike the frequent changes of pitchers.
Yeah.
11, 12, 13 pitchers perform in a game, who can remember who they are? Who can even care who they are? And then also, I would say the defense got ahead of the offense, where there are these games with 3 walks and 25 strikeouts. I don't want to watch strikeouts. I want to watch the ball in play. I want to see fielders make great catches. Let's see if they'll perform.
I don't care if I ever get...
Well, anyway, I've continued going to some minor league games. I saw a couple Coney Island, Brooklyn Cyclones games this summer, but I feel pro sports, and now it's been turned over to the gambling enterprise, and they're all in cahoots. They figured out that whether it's the NBA or the NFL or Major League Baseball, they've all taken ownership positions in the gambling companies. So it's not about the play anymore, and it's all anyway. So I think sports have entered a very bad phase. My guess is there'll be some resistance and rebellion, and also a lot of scandal, as has always happened when the gambling gets too close. Right. So anyway, I'm after being a lifelong sports fan, I'm now basically just not. And it's freed up enormous amounts of time for other things, which is great. But to come back to your question about the big challenges, I mentioned at the outset this question of, this relates to sports, the human performance. Again, you can compare a car in, let's say, an early Ford, with a 1950 and a 1980 and a 2021 Ford, and lots of things, windshield wipers, headlights, electric starter, airbags, more efficient motors. So we're used to looking at technological change in that way. And together with my colleague, Alan Curry, about 10 years ago, we had the idea to start looking at humans this way. Now, there's a big field started by people like Jose Canseco and Mark McGuire of human performance enhancement. And people think of it in terms of steroids. But we're trying to look at people in a broader way. On the one hand, with the peak physical performance, Olympic kinds of things, how fast can somebody run, how high can they jump? So these short-term physical performance, and that's been improving. And then there's the long-term, the lifetime performance, longevity, height, eyesight, things like that.
Sure.
Those, for the most part, have been improving, or with prosthetics improving and interventions. Then there's cognitive performance, IQ or literacy at one time. And then there's immune system education, which COVID has really brought front and center, the tendency to become ill or not. So we've been trying to develop an analytic framework for looking at these 4 aspects of human performance and trying to think how humans have changed, let's say, since 1900, or Americans, and then humans of the future. What will be actually, everybody says, well, windmills will be better in 2050 or whatever it may be. But we're interested in the question of what will be the human of 2050 or 2080 or 2100? Why should we assume that people will stay the same? The performance,
nutrition is better, training is better, the weightlifting machines are better, the science of all the nutrients, all
eyeglasses, hearing aids, artificial knees. So if
shoes,
both over a longer active, yes, and it's not just person. Again, it can be the swimsuit or the
tennis rackets,
sneakers,
the golf
tennis
clubs,
rackets.
yeah.
So we think the humans have been left out of the equation in a lot of futurology, including in the IPCC, for example. There's not if you read the IPCC, there's no hint that the average human, will be different in 2050 or 2100. But obviously, we will be.
Right.
I don't want to pick. I'm just saying the IPCC is the biggest venture of this kind, and they produce thousands of pages, but it's because of the scale, not because it's climate. But it's so it seems to us this is a big blind spot in thinking about the history of technology and in thinking about the future. So I hope we'll finish up some of that work in the next year or two, and I think that's really very important, because thinking that we will stay stationary while everything else changes is almost certainly wrong. So
that's great. So now, Jesse, I told you I want to keep this to about an hour or so, and we're over that right now. I always ask my guests what they're reading, and you've told us you've been reading Tolstoy and many others, Trollope and so on. But I always ask, what gives you hope? So, you don't mind, that'll be my last question then. What you've been in science now for what, 40 years or so in your career? You've seen a lot of things happen over your career. There are a lot of reasons to be pessimistic about the future. What gives you hope?
Yeah, first let me just add one more book. I'm reading
Okay,
a little known Dickens novel, Barnaby Rudge, Rudge, Barnaby Rudge. It's one of his least read books, and it's incredibly great. It's about the riots of 1780 in London. These were populist riots, so it's really like I'll say it sort of it so resonates with what's been going on in America the last few years. Anyway, it's extraordinary. I'll probably finish it tonight. Extraordinary book. So I recommend
Barnaby Rudge.
Barnaby Rudge. Anybody who's interested in populism should.
And similar today in terms of the like demonstrations in the streets, the plutocracy, the corruption in politics.
Yes.
Just to give us a little smattering of what all the things that are going on.
Nothing changes. Another Dickens that I read during COVID was Martin Chuzzlewit, which is the book in which the hero, the young Martin Chuzzlewit, comes to America in about 1840. And also, he could publish it in the Atlantic today. It's a perfect description of nothing. To think anybody who thinks that America has changed, just read Martin's visit to America. Well, I need culture is very strong.
I need to pick up some Dickens here. Clearly,
okay. But
what gives you hope?
I'll give it. I won't exactly answer your question, because I think in some ways I answered earlier part of your question, which is that I think early in my career, I wrote a paper called "Because the Brain Does Not Change, Technology Must." So I think I've mentioned zero emission power plants and magnetically levitated trains and the precision agriculture. So all those things give me enormous hope, and I've dedicated a lot of my effort to understanding how they might go. I think it relates in a way to the human performance. I think the real question, I think, for the future is still the 7 deadly sins. It's still lust, gluttony, sloth. Lust is the Me Too story, gluttony is the obesity, and sloth is the welfare question, and now the child tax credit, and wrath, of course, is the gun question, and avarice and envy, the equity question, and jealousy. I don't think I have to say much. Anyway, so I think the real questions in that sense are, I think from a technical point of view, after stating at the beginning, I'm interested in elaborating the technical vision of prosperous society that can amidst nothing harmful and spare land and sea. I think it's there. I think we can see our way to that. I think that the real questions for me are the old questions about the seven deadly sins, and we try to control those with medications and with pills and police in various ways. But the ways, and we've made progress. I mean, I agree with Steven Pinker on a lot of things, the better angels, but we have a long way to go. And when my mother asks me what I think is the biggest problem in the world, I tell her the decline of manners. And I feel like that's another book I read during COVID, great book, Quentin Durward, about medieval France. Sir Walter Scott, great writer. And there was a whole system of heralds in the Middle Ages who were, you could say, they were early diplomats. And people could be having the most horrible warfare and, eviscerating each other literally, but heralds were untouchable. If the herald came, there were all these certain ways they dressed to indicate certain things and to give them safe passage. And it seems like somehow we've I feel like there's just been a collapse in the ways we relate to one another. So I feel like that's what would give me hope. One thing that would give me hope is if we somehow recover that. But to end on a positive note, or think of War and Peace.
Less pessimistic.
The pendulums really do swing. I mean, while things like energy systems take 50 years to evolve, social moods really do swing. And in the case of in War and Peace, it's in 1793. It's the guillotine and Robespierre and Madame Lafarge and the execution of the French royal family. And in 1804, equality, whatever. And then in 1804, Napoleon is crowned emperor. So it's like in 11 years they go from one end to the other. So right. So I hope that not just in America. I think it's true in many places. So I would like to see a swing back to somewhat better manners. And again, social. As a New Yorker, I can say, having lived through from 1964 to 1989, it was one city. From 1990 to 2010 or so, it was really quite different. So I think that I'd like to see a swing toward better manners.
Civility. Well, I think that's a good place to stop. Jesse Ausubel, thank you for your time. And my guest is Jesse Ausubel. He's the director of the program for the human environment at Rockefeller University. You can find him at phe.rockefeller.edu. Jesse, I told you I wanted to have you on the podcast since I started a podcast. I've done it. A million thanks for your time. I appreciate it.
Thank you, Robert. And hello to all the listeners.
Thanks to all of you out there in podcast land. Tune in for the next episode of the Power Hungry Podcast. See you then.